just back in Berlin, my home.
Okay.
I was just in Berlin 2 weeks ago.
Yeah. How did you like it?
Awesome. It's a wonderful city.
It's a nice city.
That's what I
Glad you
hear.
liked it.
Yeah, yeah.
It has more young people than any other city. I swear to God, on the planet.
It has a lot of, yeah. It also has a lot of American expats. Like lots of young Americans.
Okay. So what, your PhD was in what area?
in statistics. So, but like I worked on a building kind of this e-learning platform for teaching data science.
Okay.
And we have been like doing studies in several classes, and we kind of rethinking our introductory statistics curriculum.
Okay.
More project based, more like
exactly. Yes. Okay.
More like not world formulas or not the calculated t-tests.
A bit more probability than confidence.
Yeah, and
levels.
more analyzing data, and more practical, less. I mean, it's still too deep the theory, but not.
Sure. Hi.
Just making sure everything's okay with the audio and video in here.
I can hear them.
Yeah. My voice works. The video
No
works. I have
videos
coffee.
or
Everything's
audio
good.
with the video?
Not that I want to have run it. Something probably has some distracting music with it. But it's better not to have that.
All right.
Okay.
We'll have
Thanks
a
for
good
checking.
session.
Okay. Okay, well let's we sort of half started already, but I'm a professor emeritus at Lehigh University. Their College of Education. I worked and still work a bit in their instructional technology department. So my minor for the doctorate was in computer science, but it was a little before the AI explosion. Before that, I was a classroom teacher. Before that, also technology director. So the idea of moving this stuff into a whole school district, that's something I know. I have an idea of what works in a classroom. Some of this stuff is based on an AI and machine learning course for K-12 educators that I teach at Lehigh. I also just finished a completely online course that I developed for Discovery Education on AI and machine learning. So this is that's the only slide in the whole program. So we can kill Keynote. Okay, so let me show you where you can find all this stuff. Hi. So if you go to mentaledge.us, that will take you to, this is one of my websites, that will take you to the place where I put lots of my course material. And you don't have to worry about the long URL because you can find all that stuff in the navigation bar. We won't be going through this, but I have a lot of material for a grad course under the AI/ML nav link with a 1, 2, 3 sort of class by class organization and a ton of links. But for this, I'll be sharing a workshop that I did at the ISTE conference last year, and a little bit of what I'm planning to do for the ISTE conference this coming year. So the 10 AI projects were for last year, the 10 more are for this year. Still under construction, I'm still working on the 10th. That's so the list kind of on my contact information is here, but it's not hard to find. So most of these, maybe all of these projects use completely free open source stuff. Most of the projects work on any device. So if something is programming or heavily gamey, it would be HTML5, so it works on a tablet or Chromebook. And generally, the projects go from younger to older, not wholly, but so thinking about from a computer science perspective, a programming course, you're interested in the code to some degree, but there's a bigger question there. You can call it a philosophical question if you want to go that route, but we talk about artificial intelligence, machine learning, and we focus on the artificial and the machine. Aren't we missing two pretty big ideas? Intelligence and learning. That used to be focused on kids in schools, but now we have a whole other domain that applies to. And so if you're thinking about young kids, even older kids, as you get into any of the AI machine learning topics, thinking about, okay, compare a machine, how it learns, to a kid, how a kid learns. And a kid starts out, really little and doesn't know much, learns at a ferocious rate, but the child's brain matures over 25 years. Whereas a machine learning system doesn't take that long to learn anymore. It doesn't learn the same stuff. Intelligence, okay, what are we good at? Math is a great thing to think about. So we think, oh, somebody's really intelligent, they're good at math. No, all that means is that math is hard for our brains, and you have to work really hard to master it. But it's really easy for a machine. So there are parts of intelligence that we're really terrible at, but something like emotion, empathy, interpreting that, we're really good at that. Machines are really terrible. So the idea of what do we mean by intelligence? What is it good at? What is it not? I'm not going to talk at all beyond a minute about the future of AI, what's going to happen, jobs, abundance, all that stuff. But one of the other the news that kids hear and adults is that, oh, the sky is falling, robots will take our jobs. But if the machine intelligence, you're welcome to come closer if you want. I won't hold anything against you if you leave early. But some of the stuff is easier to see when you're up close. But what the robots and the machine intelligence can do complements what the human intelligence can do. Rather than them competing, they partner extraordinarily well. So with that in mind, so imagine a first grader. At home, there's probably a digital device, Siri, Alexa, something like that. And that child experiences adults and maybe the child also interacting. The child may or may not have an iPad, but there may not be much AI in there. It doesn't have email, doesn't have a smartphone, right? But okay, how well does Alexa always understand you? A child may not enunciate well. Does Alexa understand mom better than you? Why? If you happen to speak German as your first language, your English has a slight accent. Okay, how about if there are kids who are immigrants or grow up in different language homes? Does Alexa or Siri understand you as well? Why? How did Alexa or Siri learn this stuff? And that can be done without having Alexa or Siri in the classroom, just a discussion. To think about, okay, is Alexa smart? Alexa knows all kinds of stuff. Is Alexa smarter than you, first grader? What can you do? Can Alexa tie shoelaces? If she had shoes, yeah. Similarly with recommender systems, usually we don't have those operating in a classroom, but how a parent buys books for their child. Go to Amazon, they say, okay, what's a good book for a 7-year-old or a 6-year-old? And what movies do you want to watch tonight? Oh, Netflix knows what kind of movies you like. How does it know that? Does Netflix, you can ask Siri, Or Alexa, who am I? Do you know my name? Where do I live? And just the kinds of things that the technology stuff knows that to help kids understand the difference. We talked about the voice recognition, voice synthesis. This is not just for first graders, because most kids all the way up through middle school have not thought about this. They have not thought about how do the systems learn, what do they know, and then we think of learning. Okay, in a school, how do you show you've learned something? Maybe you take a test. How well does that demonstrate your understanding? And yet what we expect of our devices, these things can pass tests. Do they understand? So that whole concept of again, learning, what does that mean? And this is a perfect opportunity for us to use the machines to learn more about ourselves. Before the machines, we never had a comparison to make. Okay. Let's see. How many of you use Gapminder? I see 2 hands. Okay, so let's take a look at Gapminder. Okay, Gapminder was created by a Swedish public health professor and his son. That's his son. What's special about it is that it aggregates massive data systems. And let's take a look at the tools, and specifically, let's take a look at the bubble graph, which will show up first. So what we're seeing is a graph of income versus life expectancy. Each bubble is a country, the size of the bubble is the population, the color of the bubble is the continent from which it comes. And you see we're at year 2018, but things like income and life expectancy have not been static. So let's go back to 1800 and see how this change has happened. This is processing live 125,000 data points. So as you get into the big data, this is one way to think about that. And it's getting the data from massive income databases, maybe from the UN, the World Bank, life expectancy from maybe World Health Organization. If you're a history teacher, that captures all sorts of information. So thinking about data and graphing, typically a graph with 2 axes graphs 2 variables. How many variables does this graph? Of course, income and life expectancy. What else? The country. What else? The size of the country. What else? The continent. What else? The time. That's 6 variables that you, without any effort, you adopt, you understand. So the idea here is that in data, once it gets beyond small numbers, we can't process it. It loses its meaning. But make it visual, and we get it right away, especially with a little training. So that's Gapminder. Again, all of these are in, for those who just got here, I should show you the link. All this stuff is in my site, mentaledge.us, mentaledge.us, and there's a nav button for workshops, and this is the workshop. Okay. So let's take a look at we do have this video loaded. Imagine that. Okay. So let's make it bigger. And this is an NVIDIA demo of something it calls Gauguin. And over here we have just a sea and sky. Over here this represents sea, this represents sky. We're drawing rocks right now. And then we click and the AI can make realistic, photorealistic looking rocks. You guys are welcome to come closer. You can see a whole bunch better. I didn't do that. But you can click on these, and the effects change to be various sort of artistic impressions. And that's all nice. But wouldn't it be nicer if you could do it yourself? And well, you see, there just happens to be such a site from our friends at NVIDIA, their AI playground. And if we scroll down, again, all the links are in the site. So I'm not going to emphasize the animal here. That's not as interesting. Gauguin, you just saw. To do this yourself or your kids, again, this should work in any device because it's HTML5, so Chromebooks, iPads, whatever. Hit launch interactive demo, and every kid can do it. And something that's relatively new. I think this should be called image unpainting, because if you see what's going on here, that she is being removed from the image. Watch what happens when gone.
Filled in the background. Basically
Yes.
hours.
Yes. Wouldn't that be cool to like erase parts of your own history? You have photos next to somebody you don't. Okay, Epstein would have loved that. Remove some of his incriminating evidence, I'm sure. Okay, let's see. Okay. Happily, genetic algorithms are next. Okay. So, genetic algorithms are fascinating for kids because how did we evolve? Well, we evolved through random mutation of genes. When you think of math and statistics, typically you're thinking of exact things, unless you're a statistician and you know better. But randomness is one of the core elements of this stuff. And if we think of evolution, it's built on random mutation. Some are great and prosper. Most are not so great and die off quickly. But again, we can visualize it. So, let's get him to go. Okay, so this is a program called Breve, B-R-E-V-E. It hasn't been updated since, I don't know, 2008. Still runs on Windows, possibly Linux. Runs on old Macs, not new Macs. But when we start the first generation, these guys moving way too well. So each time it changes the driver down here. Okay, that's better. Okay. So there are random parameters put in for each joint, and in the first generation, each one just kind of flails around. And let me speed it up a little bit. And this was captured over 6 hours. But I only have the beginning and the end here for you. Don't panic. So after a while, they learn to walk. And each one develops its own style of walking. Some have not gotten any further than hopping up and down, and that really don't go anywhere. Lots of dead ends. But it shows you the random mutation at work. The code, you can actually look at the code to see how to write a genetic algorithm, which is not hard for a high school programming kid. The code is in Python. The person who created this and actually created his own language called Steve to do it, and he was the only person in the world who ever programmed it. So that's a really nice system, but it's not accessible as much as it should be. Okay. Oh, okay. So this is, okay, so DeepMind did something similar. So this is using genetic algorithms for an avatar to learn how to walk, to run, to jump, that sort of thing. And it was, the avatar was not taught anything about walking or running. It was evaluated, each iteration was evaluated by how far did it get. Or in this case, did it fall through the cracks? Oops. Or speaking of running into things, if it could continue to navigate even though there are some things in the way. So again, fascinating things for kids to see. And with you who understands it a little bit, to help explain what this is. So, you know, the genetic algorithm does not come up with perfection. It comes up randomly. So you wind up with very unique system arrangements, sometimes more effective than anything we've created before. And again, genetic evolution learns through errors, meaning the errors are discarded and the successes are kept. Very powerful system, and it's extraordinarily powerful in machine learning because it takes the power of evolution but speeds it up, what, 5 million times, 100 million times, and there's no obvious limit to it, which is, wow. In terms of yeah, we don't need that. Okay, let's see. Okay. So, common information systems. So this, what something knows, especially in terms of detail and understanding, is better as a question for middle school and up. So, like if you know Wolfram Alpha, Siri gets its information from there. So, okay, how old was George Washington when he died? Most of the systems could find that out. Then ask it, how old am I? And it's like, wait a minute, George Washington is gone and you know about him. I'm here and you don't know about me. Why not? How do you know about George Washington? What are the ingredients of ice cream? It'll know that. What's the best flavor? Uh-oh. So what does it know, what doesn't it? Who's the president of a country? Is he a good leader? Okay. How many of you used Scratch? Okay. So some people think that Scratch is kind of a baby language. Its original version was built on Smalltalk 80, which had morphed into Squeak. Extraordinarily flexible languages. Extraordinarily flexible languages. Scratch is extensible. So the self-driving car is cool because you can do a self-driving bug, really simple, like 5 commands or 8 commands. 4th graders, 3rd graders can do that easily. What it teaches is the ability of sensors to provide data. So a system that's an AI that's in my phone doesn't have agency to do much. It can't walk. If I say, phone, come here, it can't do that. But something that's in a mobile environment, self-driving car, a mobile robot, a robot with legs, then it can do that. And so sensors allow it to figure out where it is, what's going on, maybe a GPS sensor, but for kids to actually program something with sensors providing the information for action. It's a powerful thing, even though it's done in a simple system. Since I mentioned Scratch, let's take a look at Cognimates. Okay, so Cognimates is based on Scratch. Let's see what is interesting here. Oh, this is neat. Okay. Rock, paper, scissors game. How does a third or fourth grader create this? Well, there's Scratch extensions that allow the student to train visually what's scissors, what's a rock, what's paper. And after a couple of, let's say, 10 different tries, then it'll run the game. And it identifies, is it scissors, is it a rock, is it paper? And that's really cool. But then asks the kids, okay, what about now? And what about if the background is different? So the idea of visual identification, which is done through machine learning, how robust is that? How weak is it? And again, those are questions that can come up as young as third grade. What does it look like? Well, here's the gap. The Cognimates site is plain old Scratch until you get down to vision training. Didn't come from MIT with vision training. These are brand new tiles for training vision. And then text training, feelings, and then connections to Twitter. There are extensions to connect to IBM Watson. And this can be done with the right adult staff for young kids. Now, adding the extensions and figuring out how they work is something that has added complexity. One teacher, 25 kids, young kids, it won't work. But if you break those kids into groups of 3 or 4, or if you have an aide or a parent, or if it's an after-school thing or a camp, it's very powerful. What else is there? Oh, translation. So with Scratch, you can translate across, like you can type something in or speak it, and along with the text training, the mic will pick up what you say. You can have it you can have it change speech to text. You can have it translate that and be spoken back to you. All in Scratch, no cost. Wow. Okay. That. And that. Okay. Oh, I didn't finish this. Okay. So, and I want to reload this page because it's been evolving all the time I've been talking. Okay, so these are genetic algorithm walkers. They're obviously sort of anthropomorphic. They have many, many joints, and random parameters are initially installed in all of them. 20 mutants are created for each generation. And then the two that are the most successful, here are the two most successful in the current generation, well, right here. They're last generation, they're the parents. Random names are produced for them. The history of the most fit mutants are shown there. So the two that walk the farthest are used as the parents to provide the genes for the new generation. That quadruped genetic algorithm I shared with you, its only metric is how far does something move. But for this, you can picture that once one falls and keeps moving, it'll be crawling. Or some will learn how to, like crawling on a belly, and others will be hands and knees. So it also has a metric of how high the head remains held. Very, very interesting. Then the really cool stuff is, oh, and there's all this like explanatory text, so it actually explains what's going on. But the student, the kid, can control the probability of mutation from one generation to the next, and the extent of the mutation. So you actually get to experiment with the pace of evolution. And like, would we advance more rapidly if we were exposed to higher doses of radiation? Or would we be harmed? Interesting question. And leaving this run for a little while shows you just gives you amazing insights. In one generation, here we have 100 and something, and down here like 1. So mutation doesn't make everybody better. It makes everybody different, and only a few are better, and lots more are worse. So again, these links are all in where I shared with you, genetic algorithm walkers. Okay, where are we next? Okay, I didn't do Kaggle here. Let's see. Let's fire up Kaggle. Kaggle is an awesome site for all sorts of data and machine learning stuff. And let's take a look at the competition. See if this is, yeah. Okay. So these are some of the active ones. There are thousands of them here. The solutions to them are posted. The solutions by different teams are posted, so you can see, like a high school group can actually examine how people have tried these different problems. So deep fake detection, ion switching, applying ML2, NCAA, March Madness, all kinds of crazy stuff. Some are very abstract, some less so, but one of the most common data sets that is used, come on, I just did something. Let's try this. How's it doing? Okay. Search. Well, maybe I can search there, okay. Okay. One of the most commonly used data sets is from the Titanic disaster, because good data was kept on the passengers, and we know which of those lived and which died. So students can actually be, it's just an example, okay, a video that explains the whole thing, the challenge, overview how it works. Okay, the CSV file for all that stuff is built in, and that's I picked one that wasn't good, because it will show you sample code for analyzing that and converting things like numbers to classes, like and names to classes, so they can be analyzed. And this is Kaggle is a notebook, meaning it's a very friendly programming environment, and it supports R and Python. R and Python are the two. R is the super duper data analysis language. R is used a lot for machine learning, kind of experimentation. Neither are real production languages. They're great for learning and for researching. They each have massive libraries that have been added to them for machine learning. And those libraries are updated all the time. So with this free stuff, you can get into some of the most advanced capabilities around. Okay, I'll be showing you something like that. Okay, classifier. Okay, that's what we're getting to. Okay, so let's take a look at, again, a very, very well-known data set of 70,000 hand-drawn digits. And while you watch, we can do this. So we can have the system process 60,000 of these. It'll take some time, a couple seconds. And you'll see how well it learns, how fast it learns. Can it, like, what do you think this is? So it's digitized to 4 different levels of grayscale on a 28 by 28 matrix. When you add all of those bytes together, you wind up with it processing 11 million data points. And let's just take a look at that and how fast it is. So this is using the TensorFlow extension, TensorFlow library, and this is a Google product, so you can go to tensorflow.org. And I'm showing you the steps to get there. Okay, let's get started with TensorFlow. And let's see the tutorials. And we're beginners, so the beginner quick start. This is something that can be done, again, on an iPad. Running like a high-powered machine learning program on an iPad or a Chromebook, that's insane. But it's all HTML5 and holy cow. So it's most convenient to run it in Google Colab, Google Collaboratory, which is very much like the Kaggle notebook. It's a very friendly environment. It can include instructions in line with the code and explanations. So you as an instructor can create these models that have built-in instructions. You can add instructions. You can invite students to change them in some way. Okay, so let's run some code. Okay. So we're gonna import some libraries, and that's fine. That's normal. And the way to execute this block of code is to click in the little between the braces. When it's processing, it'll sort of show you that, and then when it's done, the little action will stop, and now this has been done. Sometimes there's output there, sometimes nothing. There might be something just like an assignment. So all that says is, okay, we imported TensorFlow and we're calling it TF. Now we'll load and prepare the MNIST database. Okay. So, and we're putting it in a TensorFlow Keras, which is also a library format. And I've got to show you what this does, because it's just, again, this also is insane. So for machine learning, usually you have a training data set and a testing data set. You train the model on your training set, and then the test set the model hasn't seen, you run it against that to see how accurate is it on stuff it hasn't seen. So in one line, it defines the X training set and test set, which would be the actual hand-drawn characters. And then Y training and Y test would be what the characters actually are. It populates 4 data sets in one line, because the library is designed to do the kinds of tasks that are repetitive for machine learning. It's so simple. And then this needs to be in sort of between 0 and 1 for TensorFlow to work nicely. So we're just dividing by the 255 to take care of that. Okay, so now we're loading. Okay, we loaded 11 million bits right there. Okay, so this is going to be a neural network. Neural networks have layers. So we have 10 different the input shapes are a 28 by 28 matrix. So we're creating in the first layer an input layer of neurons. Second layer is the second layer of processing. The dropout is to increase robustness, because without that, if you don't insert any errors or missing values, it overtrains itself. It overfits to the exact stuff that's in the training set. Dropout means you take something like 2% of the, or maybe 20% of the neurons, and you make them inactive. So for a human, it's like if you want to learn something robustly, you have like a shot of scotch, every hour. I don't know what that would be. But, and then, why is the output layer just 10 neurons?
10 digits.
10 digits, right. So one of these will be 1, one will be 2, one will be 3, 0 to none. Okay, so let's build the model. The model's built. That fast. Okay. I'm going to ignore this part. And I'm going to ignore this part. And I'm going to ignore this part. Building a loss function, which is common. I'm going to ignore that for the moment. Okay. So now we're compiling the model. We give it an optimizer. Atom happens to be a very common TensorFlow optimizer. And then loss function we defined up there. Metrics. Well, for our crazy genetic algorithms, our metrics were distance traveled. Or it could be the time it takes for the calculation to complete. Or in this case, the metric is the accuracy. Okay. The model is compiled. Model fit is the actual training. So you're going to be seeing the training happen. Okay? Over 5 epochs. That's over 5 sort of trials. And in sort of Bayesian-ish models, it takes the output of the first trial as the input to the second trial, so it gets better and better and better based on the information that has learned from each trial. Okay. So it'll count off the seconds or minutes or hours that it takes here. Okay. First one, okay, almost 60,000 done. 5 seconds. Second try. This is 60,000 handwritten digits. Done. 5 seconds. Third epoch. And you're seeing the loss, but let's see the accuracy. Starts at 91% to 95, 96, 97. It's improving each time it goes through the neural network. Okay, with the training data, we're up to about 98% accuracy. Let's see how good the blasted thing is. So let's evaluate meaning with the test data, right? The data it hasn't seen before. That took less than a second. It doesn't, like 1/10 of a second, with an accuracy of 97.71, which is typically a little bit lower than this. So that's kind of a random weirdness, but there's a lot of randomness in here. You just saw it, and what took so long is me jabbering. This actually took less than half a minute to do the training of 60,000 handwritten digits and evaluating that on 10,000 handwritten digits.
So we're learning that how quickly we use them?
One of the things that you're learning is okay, what's the sort of system? So you learn about you teach about neural networks perhaps. Here the layers can be defined. Kids can insert a layer. They can delete the dropout layer and see how does that change the output. With a little extra code to wrap around, you could make it interactive. You take a picture of somebody's handwritten digit, and it has to be 28 by 28 matrix with, for grade levels, but that could be fed in for evaluation to see how accurate is it on digits that the kids draw in class.
This still using that MNIST data set.
Say it again?
You're still using that MNIST data
Yeah,
set.
yeah, this is the MNIST, yeah. And there are just tons of examples of this because it's not a new data set. There's so many examples, coding examples. So you as an instructor can get up to speed pretty quickly, and kids can see different ways of doing it. Okay, yeah, let's see the page. Okay. So that's the I did 10 of them in 40 minutes. Okay, let's take a look at, so again, if you came in a little bit late, I'm getting these from the 10 AI machine learning projects under the workshops heading. The 10 more are coming for that's been accepted for this coming ISTE. So let's see. Okay, this uClassify is an interesting site. Not very dramatic, but it's interesting. So uClassify is a free machine learning web service that handles text classification. And there are, I don't know how many thousands of samples here in the gallery, but let's look at, okay, 5,300. But the public classifiers, they have 96 of them here. So you can try, your kids can try in minutes, like in one class period, you can try 8 of these, and then kids can enter their own classification. You do, for entering your own, at least to keep it permanent, you need an email address. High school kids have that. But, so basically, you type something in and it will say, is that expressing a positive or negative sentiment? Gender analyzer, you have the class create some text. Feed it in there, it'll identify whether it's a boy or a girl who is likely to have written that. And again, is it going to be accurate? Of course not. That's the whole thing. It shows you the probability for each one, the probability that its choice is accurate. The idea that the machine learning and AI systems are not and cannot be exact is an important message. That this goes on probabilities. It may be a super high probability, but nobody is saying self-driving cars will be accident-free. They just have the probability of having way fewer accidents than human drivers. So we're thinking about future stuff. We're not analyzing stuff that happened in the past, like the old statistics of somebody's study that was done. We're making predictions about future events that haven't happened yet. And there will.
Does that train students to think about future products? Someone came up with the idea.
I think the idea of training kids for their future world is super important, and this is one of the ways. Yeah.
Every single job's going to have AI in it.
Yeah.
Every
Yeah.
job.
Yeah.
Teachers are going to have AI in it. They may not know it's coming, but it's coming.
And the things that the AI can do and the human teacher can do are complementary, so they'll be partners.
Well, let's
they
hope.
could be. Well, we don't know, but yeah, but they can be. Okay.
They can be.
Can be. Okay. So Angelizer, it'll tell you how old the author is predicted to be. All kinds of crazy stuff that is just fun to explore. And then you can create your own classifiers. And that's just done by entering in about 10 phrases that are then labeled. Oh, this was written by a boy, this was written by a girl, and so on. And then it uses that with its own machine language learning background to make the classifications. A very fundamental machine learning process. Now, you know that, for example, facial recognition is something that machine learning and AI has been used for a lot. And we know that China is one of the leaders of making this ubiquitous. Having face masks really fouls it up, they've discovered. But fortunately, there aren't many people on the streets. But one of the laws in China is driving, you're not allowed to use your phone. And that is, and the roadway cameras that catch that will just automatically issue a fine, like a traffic ticket. This guy fought that and won. How? Why?
He scratched his face.
All he's doing is scratching his face. And so, yeah, so the whole idea of, okay, the probability where this was trained was pretty good, but it was probably only trained on people holding the phone, not scratching their face. So, you can get into bias, all kinds of stuff like that. Okay, what else?
So somebody had to create that machine learning system in China, a Chinese AI
Right, right.
technologist, right? Or somebody
Right.
in order to be able to issue fines.
Right.
Yeah, we have so many, some human probably looked at it for a while or did something to initial train, but they have however many hours and hours of traffic data that they would have had already, or they knew who they cited already, like in person, so then they'd go back and look at the footage of that before they got physically cited.
Right. But I mean, that all that's being processed through a machine.
Yeah. There's when this guy got a ticket, there was no human intervention in the process until he complained, and then they were able to come up with what would have been evidence to convict him, and it exonerated
You see the
him.
one where they caught a criminal that he held up the face of the dead lady or whatever?
Wow.
It detected that there wasn't enough eye movement, and so it determined that the lady was dead, and then they captured him like doing something else with the lady. So that's how they caught him trying to rob her bank account or something like that.
Very interesting.
Isn't there a movie where like they stick the guy's eyeball and
It's the same.
Demolition,
principle.
not Demolition
This is
Man.
the
What
article
was it?
talking about, like right out of the movies, yeah.
Okay, so ISTE has been running an AI machine learning little course for teachers for maybe this is its third year, something like that. And I was asked to play a little role the first time. When they heard what I suggested, they stopped calling me. But they did ask me to participate in one of their live sessions. There were 3 live sessions, 2 presenters in each one. One of the other live presenters was the head of IBM Watson, so that was kind of fun for them to think I'm in that category. But the goal of the hands-on goal in that program was, our teachers will create a chatbot. And I thought that was like the most brain-dead idea for them to have, because, but this is going to be a text chatbot, and how hard is that? I mean, I did something like that 30 years ago, it's just not, you're creating a conversation, but you can do that with if-thens. But this chatbot is, this is not what I want. Okay, I want Snatchbot. Snatchbot. I forget what. Okay, I knew it wasn't .com. Snatchbot.me. Okay, and this will. Okay, but we can't show you that much of this. But so this is used by loads of companies, and if it's used in high volume, they pay for it. But you and your students can create these. There are templates already created. They're templates created for teachers to create their own chatbot. So on your home page, you can install this, and somebody can type in what's somebody's homework for tonight, what's the homework for tomorrow, whatever. And it can process that using natural language processing, not just the if-then things that you put in where it has to be precisely stated the way you expect. This is super easy to get into, and it's easy to implement in a classroom.
become really popular where you have to expense them. Like it might be a venture company.
Well, you have to hit a really high volume
Oh,
of these
okay.
to.
Yeah, yeah.
But then, so long as the entire district's not looking for their homework, you should be
That's
okay.
wonderful.
Okay, so let me just show you one more, and this is very different. But let's see.
It's actually nice. A lot of these platforms are, they start out making it very easy to build,
Yeah.
and then they just want volume users anyway. So you're never gonna
Yeah.
cross over the real threshold for them.
Or all their agreements on privacy, so much stuff. Because you're still training their algorithm by the stuff you're putting into it.
Pardon me?
Okay,
You're training their stuff by you're training what you're putting into it. The stuff you're making.
so let me just end with blah 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 blah. Let's get past this. Okay. So the Royal Institution is something that has been giving Christmas lectures since 1825, started by Michael Faraday. And Christmas lectures were designed to teach fascinating science stuff to people who didn't have a science background. And they've continued that, and the final Christmas lecture from 2019, How Can We All Win, posted February 17th of this year, is just unreal, because it has one cool demonstration after another, of probabilities, of Bayesian stuff, all related to AI and machine learning, but with an audience of mostly middle school kids. They have participation. It just is. I can't recommend this highly enough. It's just an unbelievable thing. It's an hour long. You can show it to well, you'll enjoy it for an hour. Students will enjoy it for an hour, but in a class it can be broken up into chunks, because they're about 5-minute sections on it. And in my somewhere in my list, I may have how many, like at such and such a time, this is the principle that is taught. At such and such a time, this is the principle. But all just hilarious, interesting, engaging fun. That is, I wish, and it's a perfect model for how to teach this stuff if you happen to have a nice budget and actors. So that's what I have for you. Any questions?
Great job.
Thank you. Thank you. Okay, thanks so much for coming. This was a much bigger group than I expected at 4:45, so I'm really pleased that you all came. and many of you came. A few have dribbled out just in the last 5 minutes, but that's okay. I'm happy. So okay, thanks again for coming.
Thank you.
Thank you.
Sure. So John, you could expect that you'll be seeing more of some.
No doubt.
Yeah. Yep.
Andrew.
John, don't worry.
Great presentation.
Thank you. Thank you.
I'm a tech entrepreneur. My last company was a video streaming company.
Okay.
And I know I do education and online international studies for kids. The beginning line for my program is AI is going into every single job. If you don't learn how to manage AI and learn how to be uniquely human, you will have a job.
The learning how to be uniquely human is the message that is way often missing. It's like
That's part of my talk tomorrow.
no kidding. Okay.
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 Hi, Andrew.
So we've met
Yeah, a few times, yeah.
a couple times. Yeah. So where are you now?
I'm still in Hampton.
Okay.
I've been there 15 years. now.
Okay,
I used to
okay.
be at Duquesne University.
Okay.
I've just done always, different technologies and media, media stuff.
Yeah.
But yeah, and education stuff, it's interesting, so how it's changing. But yeah, if you're around tomorrow, if you get a chance, so Dr. Rupert Ventura, the Salmon model. if you know
Sure.
that.
Yeah.
So like we developed a presentation together. We used to do it at FETC, but we can't make it in Pittsburgh. We go, yeah, go ahead and do that. So I'm just tweaking some, like would be his talking points with mine.
Okay.
like the evolution of those types of things where you use substitutes versus and jobs and
Yeah,
workforce
yeah,
and skills and throughout the research and stuff. But the history of Pittsburgh, I can buy it.
Oh, sweet, sweet.
My
That's
grandfather
nice.
had a business where they had a wagon, you know, and all that stuff. Eventually, it's just evaporated.
You've always been thoughtful that way. That's just cool. It's very cool to
Yeah,
see
they
it.
get around. I always
I'm
look
driving back
and ways
tonight.
to collaborate. So yeah.
Okay, but yeah.
Yeah, we can look and share on
Go back
online or
here,
something.
North of Philly, yeah, Bethel.
Yeah. So you've been primarily doing this in your college class, or do you also work with K-12 school districts around doing stuff?
Most of the K-12 school districts that I've encountered they don't know what to do with this yet.
Right, because some of the advanced stuff and things.
I know,
Yeah.
they need it desperately.
Yeah, because I have one of the PA Smart, it's called advancing grants, where we can
Yeah,
help
sure,
and
sure.
Like I'm trying to look at things.
Of course you
Really,
have that. Of course you
it's
do.
It's conceptual phase stuff.
Yeah,
Like
yeah.
a lot of people, then you get it more advanced. It's kind of like with audiovisual stuff. Like people have an opinion of what the screen looks like.
Yeah.
Behind stuff, and then they're like, "Wow, this is great. This is brand new." Or how fast your computer is, and then once they get used to it, they're like, "This thing needs to be bigger and brighter. This thing needs to be faster."
Yeah, yeah.
Whatever. Like the same, like baby steps. They get used to it, and then all of a sudden it's normal. Like interaction stuff, but all the privacy agreements and everything else is hard.
Oh yeah, oh yeah.
The privacy agreements and the data now, like the way that's becoming so data strict on schools and everything, and how every privacy agreement you have to review. If
Yep.
it has any type of personal element where it's tracking a kid, you have to exempt, especially like New York's coming, like California, Pennsylvania's coming too.
So in comparison with China, where they
Oh,
record
yeah.
everything, and that can be fed into machine learning
They
for
do what
kids
they want with
learning,
it, Yeah.
they will have the data to support
Right.
really intense learning, and we won't.
Right.
At least it's really hard because of the privacy agreements.
Yes, the arms race and all that stuff.
It's crazy. Yeah. But yeah.
Yeah, like so, like if you said you're not sure, like if a company's using a third-party processor to crunch all, like to provide a educational outcome recommendation or some other thing based on a data set, then you have to look at how like some schools have like maybe no third-party processing, or they have to look at the privacy agreement of the third-party company and how that they. So if I have a parent issue, like they're allowed to, by the FTC law, they're allowed to then request that data all be deleted. So you have to have a way to expunge it completely from all the
It's
systems.
like in Europe, right, to be forgotten.
Yeah,
Yeah,
right,
we
exactly.
we operate in Europe, they're far stricter than us.
Oh,
yes.
yeah, the GDPR stuff.
Far stricter, which is, I think is great, because I think the world needed that kind of leadership. We weren't providing it.
But what it means is,
No, from student affairs.
Oh, okay.
but we need ways of anonymizing the data nicely if
Right.
we hope to use it to learn from.
Yeah, because in order to do any kind of personal recommendations, you need to know who it was, or something. But it's not like if you anonymize everything, then you can't do it. It's recommended. It's good for somebody, but yeah.
And the personalized services for schools that are coming out, if they what's their data set going to be? What's their training data? It's not going to be your sample. So there are limits to how good it can be compared with how good it could be in China.
I was in here. I can't remember which country it was at the time, but the one company that they were doing speech, but they were working on kids' voices. So like Siri and all them are like I noticed that with my daughter. Like when she asks it things, it doesn't understand her. It's something with the tone of the child's voice.
Right.
So they were using programs to record stuff, and then they were processing all that children's voice recordings and training in that children's version of the speech recognition pattern kind of stuff and things. Like when they were really selling that, they were engine to other product developers that are working on kids' apps and stuff like that.
Sure.
It's interesting. And augmented reality, virtual reality stuff, I get into some of that. The combination of that with AI, and it's just this blending. So in education, the potential is there for a lot of different things.
Yeah. Ed, you asked if I do workshops, do things in schools. I do faculty training kinds of things.
Yeah, because this would be very much, I could see a bunch of people glazing over.
Yeah.
But the high school level computer science kids and stuff, and some of those other, and then from the like ability to implement in a practical way, the chatbot, and the Google Quick Draw stuff, like for elementary students are using that.
Yep.
So they just understanding what and then beyond the people that are gonna be coders, it's just the people that are the ethicists and the future ethicists and the future, like there's a lot of societal type of decision making that goes into it that you need to train those people to, whether it's philosophy people or whatever, I don't know.
I think that's
Yeah.
actually the bigger piece. It's
Yeah.
like what you have to do in terms of job, in terms of how your jobs are going to be integrated
Yep.
with this,
Yeah.
how this integration AI into your workforce and your life will impact how people are treated.
Yeah.
There's no conscience on the AI. Right? So
Right.
one of the challenges we have is there's nobody going, this isn't quite right. Let's stop doing this.
Yeah, like I talk about, one of the things I mentioned, like as an example, is like doctors. Like, there's still surgeons, and there's robotic assistant now that is better guidance, you cover that, or they pre-plan it through some, imaging technology, but they've had to relearn how to work with a robot. So a lot of people are gonna have to learn to work with robots, or work with those tools.
Everybody's
alongside.
gonna have to learn.
Yeah.
That's
Yeah, now there are jobs that are gonna go away, but there's also new jobs. Like you look at the internet, it's only 30-some years old, like 31 years old, I think, this year.
Yeah.
But the number of cybersecurity jobs and everything else, those didn't exist 30 years ago.
In the developed world, for every job that was eliminated by the internet, over 2.5 jobs were created.
Yeah.
So it's interesting to think about. And we hear the message about ATM machines eliminated the jobs of tellers. Actually, they didn't, because suddenly the big cost for tellers went away to a large degree. So the banks could create more branches, and they had fewer tellers per branch, but they had more tellers overall. So it
Yeah.
isn't.
Yeah.
So they.
And they expanded into other services and stuff.
Yeah. So they. It's system thinking, and we're not used to that.
Yeah.
It's one of my classes I teach.
Of course it is.
Oh, yeah? Where do you teach at?
I run an online international
Oh,
STEM
okay.
teamwork camp
Oh.
for